thought I should make an update video really about this electrostatic air filter that I've been made improved version. Now I made 2 or 3 different versions. I explained how I isolated the high voltages, because the high voltages basically are applied on the outside of, so that it's basically the wires are threaded through from inside the case of the computer, and they thread through. I cut a notch in the bottom of this thing, actually on this one. Let's show you on this one. There's a notch at the bottom there where the wires come through. Now the wires are connected to these terminals, right? The high voltage is on here, and the ground is on the outside one there. But because it's so exposed, I was going to originally use some little connectors, but I decided against that because it's hard to cover them up, you know. And the best way I found is to basically have copper strips. Now, you'll notice there's a difference between this one and that one. There's a rim there around the edge, right? Now, I have a strip going all the way around, which for the one high voltage. Now, another copper strip going all the way around, and then a collar goes on top. Now, if you look at this one, you'll see that there's a seam going down the middle, and that's where I injected some liquid ABS, which set rock hard as plastic, so that gives me an insulation barrier between the high voltages, and they're actually sealed underneath this collar, and you can't see the connections because it's underneath this lot. So the high voltages are completely sealed in, except for the access terminals, which are on the outside there, obviously. And once the wires are connected, I basically put great big dabs of ABS putty, I suppose you'd call it, on top. So there's a big blob of ABS plastic which sets rock hard, and that insulates the high voltage, so that there's no chance of anyone getting electrocuted. It's only about 2 kilowatts anyway. And then there's a hole there, and that's where I had the wires threaded through to go. I also had the wires threaded through. Now this is my new element anyway, which I've been working on. I'll hold it up to the light so you can see my new element design. Now, what I actually do is I paint the element with conductive paint. So I create the tracks, the actual circuit tracks for the high voltage with my brush. I literally just get my brush and I literally paint on the conductive paint to make my tracks. Because this element is in 2 halves, all I have to do is push this out and it'll pop out. So if you watch this, I'll just push this at the back, and the whole thing, the whole assembly comes out, right? So it's easy to clean. Obviously there's a grill goes over the top with one of these grills here like this to protect you, so you can pull it out. And these elements, right, can be just removed and washed in the sink. And there's 2 halves, and I've color coded these so that there's the red, there's the pink and the blue, and these 2 halves come apart, and together they form electrostatic platelets, or a bit like a capacitor, a bit like an air core capacitor, similar to that. But the current that's fed into these is limited by 10 Mega Ohm Resistors, which actually mounted inside here. Actually, on the new design are a lot better because they're actually sealed inside the thing. Now I've got these. This is another prototype I did. I'll pop this out and just push that out, and you can see the whole thing kind of drops out. If I can get it, just pull the whole thing out. Now this comes out. This is another design I tried out, but it's not as effective. The trouble is, you need a higher voltage, and I thought, well, it's a bit dangerous. I don't want to go high voltages because the gaps between them. So I built these extensions which go on there, which are, the conductive paint is on the surface of the plastic, and the current's limited by 10 Mega Ohm Resistors, which are underneath there. So if I pop these extenders off like that, you'll see there's conductive paint at the back of it, which connects to the copper electrode, which is there. And then there's some resistors, the 10 Mega Ohm resistors at the back, mounted inside this little hole, and that's filled in with ABS plastic now, so it's fully insulated, so it can't short out or anything. Keeps moisture out, you see. Anyway, this was my other design, and with these extenders on. So I decided not to use that one because it's not very effective. It just does work, but it's not as effective at gathering small particles. It seems to gather larger particles, like bits of, you know, like feathers and things like that, but it doesn't seem to work too well on pollution like smoke and nicotine. So it doesn't work as well on that, because I did a test, and so, yeah. So that's that one. And this newer one, this other one, these elements, they're much closer together, and the airflow is not constrained because there's actually a lot of gap in between each element, so the air can flow without being constricted too much. It works very well, actually. I've got one in my computer at the moment, and it's been working quite happily. These two sections come apart so I can paint them separately, so I don't get them shorted out, you know. Let me just see if I can pop these apart actually with one hand. It's not easy actually. So if I just push that one, I have to do this in steps because doing it with one hand, it's a bit fiddly. Pop that off. Nearly off. Oops. Right. I've got to paint these yet. There we go. So I've got the two sections apart now. Almost. Come off, you bugger. They slot into these little slots, these tracks here. They just slide in. And come off, you bugger. It's a bit. It's stuck somewhere. There we go. Now I've got it apart. What I do is these little arms on the end here come into contact with copper contacts at the bottom of there, right? There's some contacts in each of these slots, right? So my positive contacts are down here in a very discrete area, so there's less chance of touching them accidentally. Obviously, they're not supposed to be turned on when you're removing the filter anyway. And the negative contacts are here, which go through 10 Mega Ohm resistors. So the actual negative side is going through resistors, and those are connected through to the 10 Mega Ohm resistors at the back of these little blocks here. And the two sections, the blue is one polarization and the pink is the other polarization, and the intersectors, these are sort of taking them apart. So what I've got to do basically is what I did was, I'll just get this other one, hang on. Right, here's one I've already painted with conductive paint. One of them's painted, the other's not. So the conductive paint only runs on the area where I want it to be conductive, and so this particular one and comes into contact with, well, this is ground, so it comes into contact with the ground supply, and it's separated by the plastic here, you know, that's not painted, and then the other terminal on the outside would be painted along that edge. So I would simply paint this edge with conductive paint and around there, and bring them together, and then join the paint onto the elements, right? So the elements are actually like that one, and that's how I've done this one. So this one's also pressed together, and then let's see if I can pop this one apart as well. So I made it easy to take them apart. It's just hard with one hand, so I could easily clean them in the sink, because paint sticks really, really rock solid to the ABS plastic. No way it'll come off once it's on there. And I can literally use a toothbrush to clean it because it doesn't come off easily. Right, so there's one element. Basically, well, it's nearly all separated now. It's not completely separated, but there's one element. There's the other element, and they're insulated by the arms, which aren't painted. So basically, the conductive paint only goes to the part where you want it to be conductive. I have to mask off with sticky tape, masking tape, the area of the plastic that I don't want to get any conductive paint on. So that one's one polarization and the other elements, the other polarization. And when you bring them together, you just push them together like this, and right, so they press together, and it forms like an electrostatic capacitor, basically. That's what it basically does. So anyway, that's what I'm doing, and this is a newer design because it's got extra elements. This was a primitive early attempt just to test the theory out, and it works. And this one I've got more elements on, but they all fit inside these the same housing. So this one would also fit in there as well, like that. Just push it in, like that. But this isn't going to work because it's not finished, and I decided to build this one instead, the bigger one with the extra elements on it. Anyway, thanks for watching.